this part of the station.
Thanks, Warren. So, as Warren said, my name is Dennis Vermette. I'm an agri-coach out of Winnipeg. And I've got with me Greg Lewis from Aerial Insight, which is a local company here in Brandon. And what we're wanting to show you here today is just a demo flight of the crop cam. And it's an alternative to satellite imagery and other types of imagery that we can get out there. So before I get into the agronomy part of it, I will turn it over to Greg here. He'll tell you a little bit about Aerial Insight. They are the suppliers of the product platform. So he's got technical knowledge on the unit there. So I'll let him tell you a little bit about that while they launch the plane, and you guys can kind of watch it go there.
Great, thanks. Yeah, basically, to give you some history on it, I don't know how many people here are familiar with crop cam, and I've heard about that. There's been quite a few articles written in that on it. I've had a crop cam for about 4 years now, and I've been flying it. It's produced by a company out of Manitoba called Micropilot, and basically it's got an autopilot inside, has gyros that measure the pitch roll and the yaw, and a GPS that tells it where it is, and it flies a pattern taking pictures. Does a great job of it, but I've seen that there's kind of a gap with some of the technology in terms of taking those pictures and actually using them for something. So I've started Aerial Insight, and basically what it is, we're designing a new platform around the same technology, partnering with Micropilot as well, and adding some of the things in it, some automated flight patterns and things like that. So right now you'd have to go to a corner of a field and fly from a specific corner. With our new software, you can go to the field, anywhere you are on the field, you look at your GPS unit, you plug in the coordinates, you pass a shape file or a boundary file of to the software, you tell it what camera you're using and what spatial resolution you want, and it actually determines the flying height of the plane. You say what end lap and side lap you want, and it determines and actually calculates the pattern. You upload that to the plane, and then it flies it autonomously, so it flies it basically on its own. Right now we're developing stabilized cameras and a two-camera system, one that does near-infrared wavelengths and the other one that does color. So you're essentially getting the 4 bands of Landsat with this. Typical resolution, you're talking 400 feet is about as low as we're going to fly, but the air is pretty turbulent down there. With a 10 megapixel, you're looking at about 3 centimeters. To get 15 centimeters, which is normally what we fly, it's about 1,500 to 1,600 feet. To fly a quarter section, flight time would be about 20 minutes. And usually set up to take off, if I time myself and things go well, I can usually pull into a field, fly a quarter section, and by the time I pull out of the field with the set of batteries charged for the next field, it's usually between 40 minutes and an hour. And then there's some processing time. So it takes a bit to process them. Our software is actually going to be able to